Amazing. Could not agree more with the last insight. I think there's a lot of paths to the top of the mountain as it relates to policies. And so what we'll cover in the next couple minutes is I'll give you an introduction to what we built at Lit Protocol, kind of a unique kind of network in key management, and then talk about the work around policies, secret management, both for on-chain transactions and things like fiat transactions and transactions through APIs. I have a couple of videos in this presentation. We'll see if they work. If not, I can pull up my computer and show you. But we'll give it a shot with the videos. So yeah, as mentioned, this is a distributed key management network. Like, why is that? What do we need there? And where we can kind of go back to understand this is functionally at the most macro level, what is digital ownership? And I think it's quite well articulated in Satoshi's white paper. It is the combination of two things, which is digital signatures from keys and state management, which is ledgers. And then so first we had Bitcoin, as you know, and then Vitalik had a big insight. And Vitalik's insight was, wow, setting up a blockchain is very difficult and a huge pain. If we could make the state programmable, which is the insight of smart contracts, this becomes usable to other people, moving and ratcheting up the abstraction stack such that they don't have to set up a blockchain. The work we've done at Lit Protocol is essentially to take Vitalik's insight and apply it to the world of signing. So I'll quickly detail the architecture of this system for distributed programmable signing, some of the use cases, and then we'll talk a little bit about policies. And if the videos don't work, that'll be okay. So what we're looking at here is one, like a oversimplified view of one of these Lit Protocol nodes. You could see a couple core components. This is secure hardware inside of a TEE, and inside of that sealed environment is a threshold key share, which we'll define in a second, as well as an execution environment that makes this system programmable. Whoops, that went too much. Back. And so what we have with the given Lit Protocol network is, as you can see in green, a 2/3 threshold. And so the nodes perform a process called a DKG, a distributed key generation, to split this key amongst themselves. And these are all operated by independent node operators running in the black box. So when somebody wants to get a signature out of this network, they provide their authentication material, be it sign in with Google, some chain state, whatever it might be. It's a one-to-many operation to all of the nodes. The nodes perform their computation, say, is this Alice? And if so, those nodes then can send down their authorization to sign or combine those authorizations in the network and broadcast a transaction. The network, a single network like this, today does about 500 to 600 concurrent requests. And then the way that the system scales is horizontally. So you could imagine, like, if you have 3 of these networks running in parallel, they're managing the same secret with different shares. Happy to kind of define what that means. We now have 1,500 requests per second. And things have been going well. The network has about $110 million in assets that it manages across a wide variety of use cases, a lot of bridging stuff, a lot of vaulting stuff. The system is also used for private data in the context of identity-based encryption, but we'll talk more about the signing today. And it looks like I may try to do a hot swap here. Okay, never mind. This just has the time on it. So we'll have to use a little bit of imagination. It looks like maybe this is a PDF and the videos didn't come through. But one application is these folks called Genius Terminal. They've built a bridge. What they do is they have programmable keys on a number of supported blockchains, EVM chains, Solana, etc. And they use Lit as the underlying infrastructure for their bridge. So instead of a traditional bridge where you write to chain A, which then writes a message to chain B, in this case, they're managing a bunch of liquidity on all of the chains, exactly how the centralized exchanges do. And so if a user goes, I want to go from USDC on Base to a meme coin on Solana, the funds go to the protocol wallet on Base, and in parallel, the liquidity that is sitting on Solana buys the meme coin from a local DEX and sends it back down to the user. And so you have cross-chain swaps in the order of 1 to 2 seconds. Oh, maybe I do have the video. Let's see. That's okay. And here's essentially the way that this Genius system works, where they're using Lit as this main orchestrator across all the chains. and then periodically rebalancing between the liquidity that's stored across the system. Another way this system is used, yeah, a little bit of a presentation fail because my videos are gone, but Plurality Network, they've basically built a login method where users can log in with social auth, connect all of their various social accounts, and you could think about this as embedded wallets for users plus private data. Kind of this vision of a data backpack and user-owned data. Yeah, not sure. Are you able to hit play on those videos back there? Will that work? That's okay. I'll post this on X for people that want to check out the videos. Another use case is what Emblem Vault has done. So these are the rare Pepes from pretty OG crypto era. They were minted on Counterparty, which is a Bitcoin sidechain. And what this team at Emblem Vault has done is used Lit as a method to vault these assets, which is to say, on Counterparty, these assets are sitting in a Lit key, and then that key is represented as an NFT on Ethereum and is being traded on OpenSea. And so there's many dozens of millions of dollars of these type of assets that are managed by Lit. And the insight here is that this makes the private key something that is liquid and tradable, which is the notion of vaults. And then finally, I mentioned private data. There's a number of teams that are using Lit in the context of identity-based encryption. Really been great to work with the team at Fox on this, who is building this protocol called Verify for decentralized media syndication, whereby a media company can encrypt some data to Lit, store it on IPFS, let somebody purchase an asset on a blockchain, and after they make that purchase, they're able to decrypt that media asset. Kind of where this ends up is real-time inference and frankly RAG over media data that is attributed back to paid sources. Starts to get very, very interesting in the context of like microtransactions for individual articles and using something like this as a backend to support that type of news flow. Now let's get into agents. So that's kind of the what is Lit. So this is the general view that we have here. Right now, in a lot of the agent products that exist, it's just the default understanding that you would associate the private key as an environment variable. You would associate it with the LLM. And the insight here is instead of storing the private key at the LLM, store it in the secret management network such that when the LLM says it's time to buy 1 Bitcoin, it's time to buy 1 ETH, it's time to buy some Tesla stock via an API for like Charles Schwab, for example, the secret management network will check against a set of on-chain policies that are set by the user and only process the transaction provided that the policy passes. And so this system is kind of set up such that it can work with any generalizable secret. Private keys are, of course, core for crypto transactions, but you can also use the distributed key to encrypt some arbitrary data, like an API key. Pretty excited about what's coming up next around being able to use credit cards with headless browsers that run in the Lit network, this TEE setup. And this has been our design philosophy in terms of building agent tooling, which is agent devs, people who are coming in from Web 2, we have the responsibility to them to ratchet up the abstraction ladder once again and just consider a transaction independent of the state machine that it settles on, being Ethereum, Solana, Visa, Stripe, etc. And so if you think about this from the perspective of an LLM, these are all just tools. And the idea is how can an LLM use these tools for transactions in a way that is very, very similar for what the end state machine is, where the settlement will happen, without having that agent or agent developer have to get into the details and understand what's the difference between a Solana smart contract and an Ethereum smart contract and transacting via Stripe. And so this next graphic is looking at the same thing in just a different way, just to kind of further articulate it. At the top, we have the user, and you can see the first step, what they do is they say, here are the LLMs that can transact on my behalf, and also here are what these LLMs can do. Both of those components are written to chain. When the agent says it's time to make a transaction, it passes that up to the secret management network, which then reads from the chain. And at this point, there can also be like a predicate tie-in or any other smart contract account to tie in ahead of that allowed transaction before it is signed and broadcast. And so we've seen this implemented by about a dozen agent teams. And one of the things that we've learned is that it's difficult to implement the user auth for this. And so very excited to share what we've been working on currently, which is just pretty simple UIs for policies where we're going to provide the user auth tooling. So in this case, the user signs in with Passkey or Google or Solana wallet or an EVM wallet, supporting all of the methods there. And then as you can see in this example, the Uniswap agent is an example of an agent runtime. An LLM, maybe they have a unique trading insight, maybe they have a unique insight on how to make content, whatever it might be. And this is the view that the user will see where they are consenting to what are the types of operations that this agent runtime can do with my private key. In this example, to use Uniswap on Base with a daily spending limit. And one of the things that gets really exciting about this is slowly over time, somebody can basically make an agent and not even have to set up a website. They just say link in bio, connect their app, and this whole idea that like apps jumping between app to app to app to app to app potentially starts to go away. There, of course, maybe needs to put a need to have some kind of front end for user inputs, but pretty excited to see how this all develops. And then this is generally kind of how we're seeing the world unfolding, at least from the perspective of Lit Protocol. On the bottom, there's this distributed key management network. As of today, there's a bunch of apps that have built on this network, and that's around the private data and the asset custody stuff. And then we built this agent wallet tool that a number of agents have implemented. And then the UI framework, our kind of code name for it is Vincent. And what we're really excited about is releasing that such that people can just build an agent runtime and start commercializing that agent runtime and serve users and have to not worry about auth, potentially not worry about UIs, and just continuing to ratchet up that stack. And so this is the general idea of what we're really excited about. I have a couple other minutes, so just want to mention a few other things, less related from Lit specifically, but more around the framing on where things are going with agents. As we think about unruggable agents, the typical three components that have come up are, where do you store the keys? So the options there are things like smart accounts and using predicate or other kind of smart account modules to limit that. Some of the trade-offs with smart accounts, of course, is that you're limited to a given blockchain. You could also do it centralized. Providers like Turnkey and Privy offer centralized policy enforcement, or what we've just looked at with the distributed network. Then there's the memory, really interested in the work of this team called Recall. They've used lit encryption to encrypt agent context in memory. Pretty interesting far out stuff there around how do we create decentralized global collective intelligence. Seems like having decentralized memory ends up being a requirement there. And then of course the model execution, a bunch of really great talks earlier today on how to do private inference and private training. And so it's modular, it's mix and match. Obviously our perspective is that securing the key management and ensuring that that is not managed by a centralized party is the thing that we're highly focused on. And then zooming out a little bit further, one way that we think about this is folks are going to end up with a universal account functionally. Essentially, the thing that replaces the iPhone is your home agent, your home core assistant. And where is that going to live? What is that interface going to be? I think it's quite obvious that Apple will have a play at this, Google will have a play at this, OpenAI likely will have a play at this. And then our thinking, our hope, and what we're building towards is how can also every wallet out there be that same type of interface for people such that they can access all of the agents, the swarm, where the place where the secrets are managed is kind of like the core assistant rather than sending out secrets everywhere. Agents request the use of secrets, and that's the general mental model that we've been building from. And that'll bring me to the end of my time. Thank you so much.